Google just launched their agent-to-agent protocols called A2A, and the AI world is on fire. The GitHub repo exploded past 8,000 stars in just days, attracting huge players like Salesforce, MongoDB, PayPal, Accenture, and McKinsey. Google's calling it a new era of agent interoperability, meaning different AI agents from different companies and platforms can now seamlessly talk to each other. But hold on, didn't we already have MCP from Anthropic? Launched back in November 2024, MCP had an incredible response, hitting 30,000 GitHub stars in under 6 months, with massive adoptions from giants like Google and OpenAI. Anthropic described MCP as a USB-C port for AI applications, promising to universally connect AI agents to the data and resources they need. So if MCP was already handling integrations, what's new with Google's A2A? Google says clearly that A2A complements MCP, but what does that actually mean in practical terms? What's the real technical difference between these two protocols, and as a developer, why should you care? If you're tired of hearing vague terms like MCP connects tools, A2A connects agents, stick around because we are diving deep into the actual mechanics. No fluff, no buzzword, we are giving you real insights you can use in your projects. Here is exactly what we will learn. First, we'll quickly expand basic AI tool integrations through functional calling, setting the stage for why MCP mattered in the first place. Then we'll break down exactly how MCP changed the game by introducing a server-client architecture, making AI tool integration cleaner and far more powerful. Finally, and most importantly, we'll dive into Google's A2A protocol and uncover 3 critical differences between MCP and A2A. By understanding these distinctions clearly, you will know exactly when and why to use each one. By the end of this video, you will have a solid practical understanding of both MCP and A2A. You will see clearly how they complement each other, when each protocol makes sense, and how they can boost your AI applications. Let's cut through the noise and jump straight into the details. Okay, let's get straight into it. To really understand why MCP and A2A are such a big deal, we first need to grasp the foundation they were built on, basic AI tool integration, often called function calling. Think back to 2023, OpenAI dropped function calling, letting their models finally talk to the outside world, run codes, and use services. At the same time, ChatGPT plugins exploded. Suddenly, you could connect ChatGPT to Instacart, Slack, Warform, you name it. These were the first crucial steps in making AI genuinely useful beyond just talking. But why was this even necessary? Well, AI models, even the smartest ones, are surprisingly bad at some basic things. Ask one how many R's are in the strawberry or multiply 2 big numbers, and it might just hallucinate an answer. They have no idea what the weather is right now or the latest stock price unless you feed them that data. And while they can write a perfect email, they can't actually send it without help. Function calling fixes this. It's like giving your AI a phone book of experts it can call when it hits a task it can't handle reliably. Need math? Call the calculator function. Need weather? Call the weather API. Need to send out that email? Call the email tool. So how does this function calling actually work under the hood? It really boils down to 4 key steps. First, step 1, you, the developer, actually build the tools. Look at this simple Python code. Here we've designed basic functions for adding, subtracting, multiplying, and dividing numbers. These are the concrete tools our AI will be able to use. Next, step 2, you need to tell the AI what tools it has access to and how to use them. You list the functions. Look at this code snippet. We are creating a description for each function, telling the AI its name, what it does, and crucially, what information parameters like A and B for our calculator it needs to work. Now for step 3, the AI has to select the right tool for the job based on the user's request. If someone asks what's 5 plus 7, the AI needs to figure out it should use the add number functions with A equal to 5 and B equal to 7. There are 2 main ways to make this happen. The easiest way is to use the API approach. See this code using OpenAI's library? Most providers now have a built-in way where you can just pass the list of tools and the API call tells you which function the AI chose and the arguments it extracted. Alternatively, if your model doesn't have built-in support or you want more control, you can use a clever prompting. Look at this example prompt. You basically describe the tools within the prompt itself and ask model to output its choice in a structured format like YAML, which you then pass. Finally, step 4, call the function. Once the AI has picked the function and figured out the arguments, your system actually runs the code. This Python snippet shows how you would map the function name chosen by the AI back to the actual Python functions and execute it with the provided arguments. So function calling is powerful. It lets AI breaks out of its text-only box. But here is the giant headache. The big limitation that paved the way for MCP, there was absolutely no standard. Look closely at how different AI providers expect you to describe the function parameters. OpenAI uses a parameter object with types and properties, and Databricks Cloud uses import schema instead. This might seem like small differences, but they mean your tools are instantly incompatible. This lack of standardization creates real problems. You couldn't easily build a tool once and have it work with different AI AI models like GPT-4, Cloud, or Gemini. If you are using a closed systems, you couldn't add your own custom tools at all. Every time a new AI system pops up, you would potentially have to rewrite your tool integration for their specific format. And getting a Python-based AI to use a tool written in JavaScript, that's another layer of complexity. Sure, ChatGPT plugins try to create some standard, but they were locked into OpenAI's world and needed your tool to be accessible over the internet. The industry desperately needed a universal way, a common language for AI to talk to tools, something that worked across all vendors, whether your AI was running in cloud or locally. This standardization mess, this inability for tools and AIs to easily connect regardless of who built them, that's precisely the problem MCP set out to solve. And understanding this problem is the key to seeing why MCP was such a leap forward, which we will dive into right now. Okay, so seeing the problems with basic function callings, meaning that everyone did it differently, creating a compatibility nightmare. This is where MCP, the model context protocol from Anthropic, steps in and completely changes the game. So what's MCP? Launched back in November 2024, MCP tackled that standardization problem head-on. It creates a universal interface, a common language that lets AI systems talk to any external tools, no matter who built either of them. Anthropic called it a USB-C port for AI. Maybe think of this more like a Bluetooth for AI. Just like any Bluetooth device can connect to any Bluetooth-enabled phone or computer, any MCP tool can connect to any MCP speaking AI agent. They just need to speak the same protocol. How does it achieve this? The absolute core idea, the magic of MCP, is to splitting the system into two distinct parts, a server and a client. The MCP server is actually where your tools live. Your calculator code, your weather checker, your connection to Salesforce that all reside on the server. Crucially, the server runs completely separate from the AI model itself. It can be written in Python, JavaScript, Rust, whatever you want. The MCP client, on the other hand, acts as the bridge. It usually lives alongside within the AI agent. Its job is to talk to the server, figure out what tools are available, help the AI format its request correctly using the MCP standard, and handle sending these requests to the server and getting this result back. Look at this diagram. It shows the flow. The client asks the server what tools it has, and AI working with the client decides which tool to use. The client tells the server to run that tool with specific inputs. The server runs it and sends the result back to the client. This clear separation is the key. Your tools can be developed, updated, and deployed completely independently from the AI models that use them. Let's make this concrete. Let's rebuild our simple calculate example, but this time using MCP. First, step 1, implementing the functions. This now happens on MCP server. Look at this Python code using fast MCP library. We create an MCP server and then use decorators like at mcp.tool to expose, add, subtract, multiply, and divide functions. Notice what is not here. There's no OpenAI specific code, no Anthropic specific code. It's just a calculator server that speaks the MCP language. We can fire this up and it just sits there ready to perform calculations for any client that connects. Now step 2, listing the functions. This happens on the client side. See this client code? It is responsible for connecting to our calculator server. It uses a standard MCP command list tools to ask the server, hey, what tools do you have available? The server responds with the schemas, the descriptions of the add, subtract, multiply, and divide functions, all formatted according to the MCP standard. Step 3, selecting the function. This also happens on the client side, usually involving the AI model. Look at this selection code. It is very similar to the prompting approach we saw earlier. The client takes the list of tools discovered from the server in step 2. Look at user's question like, what is 1567 times 428? And uses the AI to figure out the correct tool name, in this case multiply, and the specific inputs or parameters needed for that tool, which will be numbers from the user requests. The crucial difference here is that the available tools aren't hard-coded. They come directly from the MCP server. Finally, step 4, calling the function. Again, this is handled by the client. Check out this code example. Now that the client knows the target tool name, multiply, and the necessary parameters it just extracted, and packages this information up, and then sends it over to the MCP server using a standard command from the protocol, specifically call tool. The server receives this request, locks up the multiply function, executes it with the provided numbers, gets the answer, the calculated result, and sends the result back to the client, all formatted according to the MCP standard. So what does this server-client architecture and standardization protocol actually buy us? 2 huge benefits. First, universal compatibility. You build an MCP to server once, maybe for interacting with the company's internal databases. Now, any AI agent that speaks MCP, whether it is from OpenAI, Anthropic, Google, or one you build for yourself, can use that tool without any changes. Similarly, MCP-compatible agent can instantly use any available MCP tool. It breaks down the vendor silos. Secondly, implementation freedom. Because MCP only standardizes the communications between the client and server, not how they are built internally, you have total freedom. Your tool server can be in Go, running on-premise, using complex internal logic. Your AI client could be in Python, running in the cloud. You can update your tool's implementation, fix bugs, or improve your performance without ever touching the AI agent code, as long as the MCP interface remains the same, and vice versa. Every piece can evolve independently. MCP essentially creates the built once, use anywhere ecosystem for AI tools. It allows specialized capabilities developed by anyone to be plugged into any compatible AI brain. This is a massive step forward. But if MCP handles connecting AIs to tools so well, what gap was left for Google A2A to fill? That's where things get really interesting and where we uncover the key differences. Let's dive into A2A next. Okay, we have MCP connecting AI agents to tools like calculators, databases, or APIs. That's powerful. But what happens when the task is too complex for just one agent and its tools? What if the task requires different kinds of expertise working together? Think about planning the dream vacation to Hawaii. Yes, you need calculators, adding up flight costs, hotel nights, activity fees. Our MCP calculator tool is perfect for that. But planning the whole trip, that involves finding flights for specific dates, comparing hotel locations and reviews, researching activities based on your interests, maybe checking the historical weather for June, and juggling all of that within a set budget. No single calculator tools, no single flight API tools can handle that entire complex planning process. It requires different specializations, a travel expert, a budget analyst, maybe even a local guide, all collaborating. This is exactly the problem Google's agent-to-agent protocol, or A2A, is designed to solve. Released just this past April, A2A enables different specialized AI agents to talk directly to each other, delegate tasks, and work together as a team. So what's A2A? It is a standard way for AI agents to communicate and hand off work to one another. If MCP connects an agent to a tool like our calculator, A2A connects an agent to another agent. Think of it like this. MCP lets your agent use a specialized tools, like using the calculator for the budget math. A2A lets your agent consult with a specialist agent, like talking to an experienced travel agent or a financial advisor agent. Let's go back to the Hawaii trip. Imagine you have your main personal assistant agent. Planning the trip is too much for it alone. Using A2A, it can now act like a project manager. You ask your personal agent to plan the trip. It realizes it needs help. Using A2A, it delegates specific subtasks. It asks a specialized travel agent, find flights and hotels for these dates and budget. It asks a local guide agent, suggest some cool activities in Maui for a couple. It asks a budget agent, take these potential costs and tell me if it fits within $3,000. Each specialized agent does its part. The travel agent might use its own tools, perhaps collected via MCP, to search flight and hotel databases. The local guide consults its knowledge base. The budget agent critically might use our trusty MCP calculator tool to do the precise math required for the analysis. Then, via A2A, these specialists report their finding back to your personal agent. The travel agent provides flight options. The local guide suggests tools. The budget agent gives the financial breakdown. Your personal agent then takes all these pieces and assembles the final complete vacation plan for you. So how does this coordination actually happen technically within A2A? First, step one is agent discovery. Your personal agent needs to find the right specialist. Look at this code snippet using the A2A client. It's searching for the agent based on their capability. Each A2A agent publishes an agent card. Think of it like a resume or business card, describing what it is good at, like travel planning or budget analysis. Your agent uses these cards to find the right help. Next, step two is task delegation. The personal agent creates tasks for the specialists it found. Check out this code example for sending a task. Notice something important. Unlike MCP, where you provide very specific parameters like A equal to 5, B equal to 7, A2A tasks are often described in natural language. The personal agent tells the travel agent something like, find affordable flights to Hawaii from LAX and hotel options in Maui for 5 days in June for a couple. The specialized travel agent uses this intelligence to understand and execute this high-level instruction. Then, step 3 is monitoring and the results. Delegating isn't enough. The personal agent needs to know when the work is done. See the code? The agent can check the status of the tasks as set out. A2A tasks have a life cycle. They go from pending to running, maybe producing intermediate updates, and finally completing or failing. When the travel agent task is complete, the personal agent can retrieve the results, like the list of flight and hotel recommendations. Finally, step 4 is integration. The personal agent gets us all the results from the different specialists, travel plans, activity suggestions, budget confirmations, and intelligently combines them into that single coherent vocation plan presented back to you. Now, the really powerful idea is that MCP and A2A are not competitors. They work together. Look at this graph. Your personal agent uses A2A to coordinate the team of specialists. But then each specialist agent might use MCP to connect to the specific tools it needs. The travel agent uses MCP to talk to the flight and hotel APIs. The budget agents use MCP to talk to our calculator tool. The local guide uses MCP to query an activity database. You get this layered approach. A2A handles the high-level collaboration between intelligent agents, while MCP handles the lower-level connection between an agent and its specific non-intelligent tool. These combinations allows for building incredibly sophisticated AI systems that can tackle complex, multifaceted problems by assembling virtual teams of specialized agents, each equipped with the right tools for their part of the job. Understanding this synergy is crucial, but to really know when to use which, we need to pinpoint the key technical differences in how they operate. Let's break down 3 critical distinctions next. Okay, let's get down to the real technical meat. You often hear simple explanations. MCP connects AI to tools and A2A connects agents to agents. But honestly, that's too simple. The line between a tool and an agent can get blurry really fast. An agent can act like a tool, and some complex tools start to look like simple agent. If you really want to know when to use MCP versus A2A and how to make them work together effectively in your projects, you need to understand the fundamental design choices, the architecture DNA that makes them different. Forget the buzzwords. Let's break down the 3 critical technical differences. Differences number 1, communication style. How do they actually talk? MCP uses structured schemas. Think of it like filling out a very precise form. Look at this MCP code example for currency conversion. You have to provide parameters like currency from, currency to, and amount. And they have to match the tool's definition exactly. If the tool expects currency from and you send from currency, it breaks. There's zero room for interpretation. It is rigid, structured data in, structured data out. Now look at A2A. It primarily uses natural language. See this A2A example for the same currency conversion task. We are not sending structured parameters. We are sending a natural language message inside of a task object, something like how much is $100 in Canadian currency. The receiving agent uses its own intelligence to understand that request. You could phrase it differently, convert $100 USD to CAD, and a capable agent should still figure it out. So to recap, MCP is like a direct command with specific input. A2A is like having a conversation. Why does this matter so much? MCP's structured approach is perfect when precision is not negotiable. Think financial transactions, scientific calculations. It is reliable, predictable, and efficient for high volume, standardized requests where you know exactly what data the tool needs. A2A's natural language approach shines for complexity and ambiguity. It is better suited for tasks that do not fit neatly into predefined function parameters or where the requirements might involve. It is like talking to a helpful expert who can figure out things out, asking clarifying questions if needed, and handle variations in how you ask. Difference number 2, task management. How do they handle the work itself? MCP is based on function calls. These are essentially single-shot operations. Look at this MCP code trying to get weather. The client calls the get weather tool. You typically expect a direct response, either the weather data or an error. It is often used for quick single-shot interactions. A2A, on the other hand, manages complete task life cycles. It explicitly understands that tasks take time and go through stages. Check out this A2A code snippet checking on a task. The protocol itself defines states like pending, running, completed, or failed. An A2A task can be long running. The requesting agent can check its status, see how long it has been running, and crucially, even receive partial results or progress updates before the final completion. This visual workflow comparison really highlights it. MCP is a simple request response. A2A involves sending a task, getting it acknowledged, and then potentially checking back multiple times to monitor progress and get the final result. So when does each approach make sense? MCP's immediate function calls is great for quick, discrete operations, things like our calculator looking up a single piece of data, sending out a simple command. Each call is independent, stateless, and we need the results or the failure right away. A2A's managed lifecycle is built for complex, multi-stage work. Think research tasks, report generations, coordinating multiple steps like our Hawaii vacation planning. It is essential when tasks take time, when you might need interim updates, or when tracking the progress or delegating work is important. Difference number 3, capability description. How do they describe what they can do? MCP defines capability using precise function specifications, often using JSON schema. Look at this MCP definition for a send email tool. It details exactly what parameters are needed. 2, subject body, CC, and specify the data types like strings or array, constraints like max length or email format, and which ones are absolutely required, and leaves nothing to chance. It is like a detailed technical instruction manual for using that specific function. A2A describes capability more generally using what is called an agent card. See this example agent card for email specialist agent. It gives a name, a general description like I can help compose, send, and manage emails professionally. Then it lists broader agent skills like email composition, email organization, providing natural language description and example of tasks it can handle, such as draft a follow-up email or help me organize my inbox. It is much more like a professional resume or service description outlining areas of expertise, rather than a rigid list of functions. This reflects a fundamental difference in philosophy. MCP focuses on the how. It tells the tool exactly how to perform a specific predefined operations using precise instruction. Look at the diagram showing the client giving step-by-step instructions. A2A focuses on the what. It describes what capabilities an agent possesses, what goals it can achieve, and trusts the agent to figure out the best way to accomplish the task using its expertise. The diagram shows that agent being given a high-level goal like scheduling a meetings, and the specialist figures out the necessary steps. For you as a developer, this changes everything. Developing for MCP, building a reliable specific function with clear inputs and outputs. You are crafting precise components. Developing for A2A means building agents with broad expertise, capable of understanding context, handling ambiguity, and achieve goals across a range of related tasks. You are cultivating expertise, not just implementing functions. MCP gives you predictability and control. A2A gives you flexibility and adaptability for tasks that require judgment. So you see, these differences are not just about one being better. They make MCP and A2A perfectly suited for different jobs and incredibly powerful when used together. You use A2A for the big picture, coordinating specialist agents, breaking down complex problems, manage sophisticated workflows, and you use MCP for details, enabling those specialist agents to reliably execute specific, well-defined tasks using standardized tools like our calculator and API call or a database query. Together, they pave the way for our AI system that can collaborate like a skilled team while executing tasks with the precision of a machine. They are truly complementary protocols for building the next generation of AI. Alright, let's bring it all home. We have covered a lot of ground, starting from the basics of how AI models first learn to use external tools, all the way to the sophisticated protocols like MCP and Google's new A2A. Here is the big picture, the 5 key things to remember. First, we saw function calling. This was the initial breakthrough, letting AI models reach out beyond their text-based world to do things like calculations, check real-time data, or trigger actions like sending an email. It was like giving them a phone to call experts. But the big problem, everyone have their own phone system, their own way of doing it, which made building universal tools a nightmare. Then came MCP, Anthropic's Model Context Protocol. MCP tackled that standardization mess head-on by creating a server-client architecture and separated the tools from the AI agents using them. This means you could build an MCP tool once, and any MCP-compatible agent could use it, regardless of who made the agent or the tool. Sync Bluetooth for AI tools. MCP excels at precise, well-defined single-step operations where you need reliability and a clear contract. Next, we explore Google's A2A, the agent-to-agent protocol. This protocol shifts the focus from connecting agents to specific tools to connecting agents to each other. A2A is built for collaboration, enabling teams of specialized AI agents to work together on complex, multifaceted problems like planning that Hawaii vacation. It uses more flexible, natural language communication and manages tasks over their entire lifecycle, compete with status updates and partial results. It is designed for coordination and teamwork. We then dove into 3 key differences: the communication style of structured data versus natural language, task management of single short calls versus full life cycles, and capability description of precise functions versus general skills. These technical distinctions are crucial because they reveal why MCP is suitable for tool integration and why A2A is built for agent collaboration. They are fundamentally different approaches. And finally, we address the practical question: which protocol should you use? The answer truly depends on your project. If you need reliable, standardized access to specific tools across different AI systems, MCP is a fantastic choice. If you are orchestrating complex workflows involving multiple intelligent agents delegating tasks to each other, A2A provides the framework. But often, the most powerful approach will be to combine them. Use A2A for the high-level agent coordination and MCP for the precise tool execution needed by those individual agents. Whether you end up using direct function calls for a specialized system, adopting MCP to build universal tools, leveraging A2A for complex agent teamwork, or mixing and matching, understanding the strengths, weaknesses and underlying philosophies of this protocol is the key. It empowers you to make informed decisions and build more capable, robust, and intelligent AI solutions for the future. If this video was helpful, please like and subscribe. See you next time.